Good morning, students. This is class 10th physics, chapter 12, electricity. Topic is numericals on series and parallel resistor. Okay, so children, in the last class we had done the derivation for the equivalent resistance when the resistors are connected in series. So we know that when the resistors are connected in series, their equivalent resistance Rs is equal to sum of all the resistances connected in series, right? Now, when the resistors are connected in parallel, when they are connected in parallel, the formula for equivalent resistance is 1 upon Rp equals to, where Rp is the equivalent resistance in parallel, equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. Right, children? So if you compare, children, the value of equivalent resistance when they are connected in series, that value of equivalent resistance will be more as compared to the value of equivalent resistance in parallel when they are connected in parallelly, right? So in series, you are going to get the equivalent resistance more, and in parallel, you are going to get the equivalent resistance less. Okay. And if here the resistance is more, then the value of current, that is I, will be less because resistance is more. And here as the value of resistance is less, the value of current will be more. Okay, beta. So with this, we will start with the numericals. Let's start with question number 1. What is A, the highest, B, the lowest total resistance that can be secured by combination of 4 coil of resistances, 4 ohm, 8 ohm, 12 ohm and 24 ohm. So children, here you have to find the highest resistance. So children, highest resistance, we know it is the total resistance when the resistors are connected in series. So for highest total resistance, we need to connect them in series. And for lowest total resistance, we need to connect them parallelly. So let's start with it. So children, the highest total resistance is obtained when the resistances are connected in series. And we know the formula when they are connected in series is Rs, simple addition. Rs equals to R1 plus R2 plus R3 plus R4. Let's put the value of R1 as 4 ohm, R2 as 8 ohm, R3 as 12 ohm and R4 as 24 ohm. So when we put these values over here, we will get the total resistance in series as 48 ohm. So this is the highest total resistance possible with these 4 resistors. Okay. Now let's see what is the lowest total resistance. So for lowest total resistance, we need to connect all these 4 resistance in parallel. So let's connect them in parallel. So when they are connected in parallel, we know the total resistance will be Rp equals to 1 upon Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Substitute the value of R1, R2, R3 and R4. We will get 1 upon Rp equals to 1 upon 4 plus 1 upon 8 plus 1 upon 12, 1 upon 24. Now, if you want to add them, we need to take LCM, right? So after taking the LCM and solving it, we are going to get 1 upon Rp equals to 12 by 24 and 1 by Rp is 1 upon 2. Now children, we need to find the value of Rp, not 1 upon Rp. So what we will do, we will take the reciprocal on both the sides. So taking the reciprocal, you will get Rp equals to 2 ohm. So this is the value of lowest total resistance when 4 ohm, 8 ohm, 12 ohm and 24 ohm are connected in parallel. Okay, beta. Now let's move towards question number 2. Let's read the question now, here, children. Here, 2 resistances are there, right? When connected in series, the resultant is 10 ohm. So you know when you are connecting them in series, their resultant will be by adding them, right? So suppose here you are having 2 resistances, X and Y. So when they are connected in series, RS, series X plus Y, what is the answer? 10 ohm. So 10 ohm. This is your first equation, that is X plus Y equals to 10 ohm. Right? So two resistances, when they are connected in series, there is a resistance. Let's read the question further. But when they are connected in parallel, the resultant is 2.4 ohm. Find the value of each resistor. So you have to find the value of X and Y. Now what does the second line says that? It says that when you're connecting them in parallel, when you're connecting them in parallel, the answer is 2.4. So you know the formula for parallel, 1 by RP equals to 1 by R1 plus 1 by R2. But R1 is X, we have supposed, and R2 is Y, right? And RP value 1 upon RP is 2.4, right, beta? So you are going to solve these two equations. You are going to use these two equations and you are going to find the value of X and Y. Okay, so let's start with it. So starting with the solution, we are supposing the two resistances to be X and Y. Let the two resistance be X and Y. So when they are connected in series, the formula is Rs equals to R1 plus R2. But when they are connected in series, their resultant, their answer is 10. So X plus Y is 10. This is equation number 1. Got it? Now children, when they are connected in parallel, we know the formula is 1 upon Rp equals to 1 by R1 plus 1 by R2. RP value is 2.4. RP value is 2.4. So 1 upon 2.4 equal to 1 by X plus 1 by Y. Now if I want to remove the decimal, I will divide it by 10, right? Dividing it by 10, so 10 will go in the numerator. So we'll get 10 by 24 equals to 1 by X plus 1 by Y. Now here you can take LCM and you can add. LCM is XY. So here we need to multiply by Y and here we need to multiply by X. So here you will get Y plus X upon XY, right? Now XY will go this side with 10, 24 will come this side. So you will have 10XY equals to 24X plus Y. But X plus Y from equation number 1, we know it's 10. So let's put the value of X plus Y as 10. So you will get 10XY equals to 24 into 10. So X plus Y equals to 24. This is your important equation number 2. Your first equation is X plus Y equals to 10. Your second equation is X into Y is 24. Now what you will do, as you do in maths, you are going to use the substitution method, right? So from this equation, you will substitute the value of X. X can be written as 10 minus Y. So this value of X, we will substitute in this equation. So on substituting the value of X as 10 minus Y in this equation number 2, we will get, instead of X, what we will write? 10 minus Y. Y as it is equals to 24. So here you can see that is X into Y is 24. Instead of X, we have written 10 minus Y into Y equals to 24. Multiply Y inside, 10Y minus Y into Y is Y square equals to 24. Now Y square will bring this side, 10Y we will bring this side. So minus Y square has become plus Y square, plus 10Y has become minus 10, and 24 was here only, it's 24. What is left on the other side? Nothing. So that is equal to 0. Now this is your quadratic equation, right, beta? Now if you solve this, you will get the value of Y as 6 or 4. So when you substitute the value of Y as 6 in your equation, that is X plus Y equals to 10. X plus Y equals to 10. If you substitute Y as 6, then X plus 6 equals to 10. Then X value will be 4, right? But when you substitute the value of Y as 4, then the value of X will be 6, right? So these are your two resistances possible. One is 4 ohm and the other value is 6 ohm. Got it, beta? Okay, let's move to question number 3. Let's read the question carefully. This is very, very important question, children. Okay, children, we know that resistance, it depends upon length. More is the length, more will be the resistance. Less is the length, less will be the resistance, right? So here we are having a piece of wire having resistance R is cut into 4 equal parts. So as you are cutting them into 4 equal parts, means you are having 4 pieces of wire of equal length. And as you have divided the length by 4, your resistance of each piece will also be equal to R by 4. Resistance will also become 4 times less. As you have made the length 4 times less, the value of resistance will also become 4 times less, right? What do you need to do? How will the resistance of each part compare with the resistance of original? So you have to find the resistance of each part. Next, if the four parts are placed in parallel, how will the joint resistance compare with the original? So you are connecting all the 4 parts of the wire in parallel, right? So first, let's take a piece of wire and cut them into 4 parts. So the resistance of the piece of wire is R, right? Now, when we are cutting them into 4 parts, their length will become L by 4. So as their length is becoming L by 4, suppose the wire is of 40 centimeters. Now, if I cut it into 4 equal parts, then it is L by 4, 10 by 4. So 10 centimeter each. So as the length is becoming L by 4, its resistance will also become R by 4. So when the wire is cut into 4 equal parts, the resistance of each part will be R by 4. Got it, beta? Okay. Now next what they are saying in the question, that all the 4 parts you are connecting them in parallel. So can you see all the 4 parts are connected between 2 common points, right? Okay. Now we have to find the effective resistance. In parallel, you know the formula. 1 upon Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. R1 value is R by 4. R2 value is R by 4. R3 value is R by 4 and R4 value is R by 4. All values are same, right, beta? So we'll put those values over here. So 4, which is in denominator, it will go up in the numerator, right? 4 will go up. So we'll have 4 plus 4 plus 4 plus 4 upon R. So it is 16 by 4. Now in the question they have asked you to find how will the joint resistance compare it with the resistance of original wire. So original wire resistance, with that you have to compare it. So your value of 1 upon Rp is 16 by R. So if you want to find Rp, you have to take reciprocal. So Rp equals to R by 16. So here you can compare the value of the joint resistance with original. So the value of the joint resistors which are connected in parallel is 1 by 16 times the value of the original resistance. So the resultant resistance will be original divided by 16 times. That is R by 16 times. Okay, beta? Fine. Is this clear? Okay, let's proceed further. This is our question number 4. Let's read the question very carefully. Very, very important question. 12-volt battery. So voltage is given to you 12 volt. Is connected to an arrangement of resistance given below. So this is the circuit diagram given to you in the question. Okay. Now, what we have to calculate? We have to calculate the total effective resistance. So we have to calculate the total resistance. And then you have to calculate the total current which is flowing in the circuit. Okay. So let's start. First, we will find the total resistance. So children, here if you see, these two are connected in series, one after the another. These two are connected in series, one after the another. And then their answers are connected in parallel to each other. That is between 2 common points, A and B. So first we will find the resultant of this series line branch, and then we will find the resultant of this series branch, right? So first we will find the resultant of the first series branch. Suppose this is first branch, this is second branch. Now for the first branch I can write R series number 1 branch, that is R1 plus R2, that is 10 plus 20. Here you can see 10 plus 20. So RS1 is 30. So can I replace this branch with, instead of this, can I make a single resistor like this? And can I write 30 ohm here? Yes, because uska resultant kitna aaya? 10 plus 20 is 30. Similarly, children, the resistance of series of the second branch is equal to, suppose it is R3 plus R4. So it is 5 plus 25. So 5 plus 25 is 30. So instead of the second branch, I think I can make one resistor, because uska answer kya aa raha? Equivalent is 30 ohm. Now this 30 ohm and this 30 ohm, they are connected parallelly. So now we will apply the formula of parallel to these two 30 ohm resistances, and we can find the total effective resistance of this arrangement. Right, but I hope I have made myself clear. So let's proceed further. So as you can see here, we have named the resistors R3 as 5 ohm and R4 as 25 ohm. Then we found out the series was 30. Now these two 30, they are connected in parallel to each other. So we will apply the formula of parallel. So 1 by Rp is 1 upon Rs1 plus 1 upon Rs2. That is 1 by 30 plus 1 by 30. LCM is same. So it will be 1 plus 1 by 30, that is 2 by 30. 2 ones are 2 15s are. This is the value of 1 by Rp. You want the value of Rp. You will do reciprocal. So Rp is 15 ohm. This is the value of total resistance. You are given in the question the voltage is 12 volt. What do you have to find? You have to find current. So here children, we can use Ohm's law. V equals to IR. But instead of R, we will put RP, because that is the final answer, na? Okay. So I will be nothing but it is equals to V upon RP. So V is 12, RP is 15. So your current is 12 by 15, and 12 by 15 will come out to be 0.8 ampere, right? So the total current is I equals to V by R. This is from Ohm's law. V is 12, R, the total resistance is 15. 12 by 15 is 0.8 ampere. Okay, beta? Chalo. Let's move towards the last numerical for today. Here also you have been given a circuit diagram. In this circuit diagram, you have been given some values. What do you need to find? Here R1 is 5 ohm, R2 is 10 ohm, R3 is 30 ohm. And as you can see, all the three resistors, they are connected between two common points. So they are in parallel, because current is having many paths to flow. So they are in parallel, right, beta? What else is given? Voltage is given 6 volt, right? These are the values of three resistances, and one voltage is given to you. What we have to find? We have to find the current, total current in the circuit, and the current through each resistor. Means 5 ohm mein kitna current gaya? How much current did flow through 10 ohm? What amount of current did flow through 30 ohm? So suppose your current I is flowing, this I will be divided into I1, I2, I3. So you have to find the value of I1, I2, I3, and then you will add them all, so you'll get the value of I, right, beta? And third thing, what you have to find? You have to find the total effective resistance. So total effective resistance is simple. As you can see, they are connected in parallel. So we'll simply apply the formula for parallel and we'll get it, right? So firstly, let's start with the value of current, that is I1, I2, I3. So children, as you can see that there are three branches for current to flow. So current is different, I1, I2, I3. But what is same in parallel? Voltage will be same. What will be the voltage through each resistor? The voltage will be same, that is 6 volt. So the voltage through 5 ohm resistor will be 6 volt. The voltage through 10 ohm resistor will be 6 volt. and the voltage through 30 ohm resistance will also be 6 volt. So V value will be 6 for all the three resistors, right? We have to find the value of I. So children, we know Ohm's law. If we apply Ohm's law for the first resistor, that is R1. So Ohm's law is V equals to IR. For the first one, it will be V equals to I1 R1. Why we did not put V1? Because V1, V2, V3, they all are same, right? And the answer will be 6. So here we are letting it as V only. So let's put the values. Here the value of V will be 6. Value of I1 we don't know, but value of R1 is 5 ohm. So if we make I1 subject of formula, I1 is 6 upon 5 and 6 upon 5 is 1.2 ohm, right? Similarly, applying Ohm's law for second resistor, that is 10 ohm. So Ohm's law is V equals to IR. So V will be as it is, but I is how much through second resistor? I2. Resistor is R2. Voltage is 6. I2 value as it is. R2 is 10 ohm, as you can see here. So I2 is 6 upon 10, that is 0.6 ampere. Let's apply Ohm's law for the third resistor. Ohm's law is V equals to IR, but as third resistance, V will be V, but current is I3 and resistance is R3. Voltage is 6 volt for each. I3 value as it is, R3 value will put as 30 ohm. So I3 is 6 by 30, that is 0.2 ampere. So this I1, I2, I3 are the values of current flowing through R1, R2 and R3 respectively. Right. Now if you want to find the total current. So total current I is what? I1 plus I2 plus I3. Similarly, we'll add here all the three I1, I2 and I3 current and we'll get the total resistance. So if you add them all, let's do it. Then we'll check with the second also. So I equals to 1.2 plus 0.6 is 1.8. Right? 1.8 plus 0.2 is 2 ampere. So we found out on adding all these three, the current is 2 ampere. Okay, we'll check at the last. Now let's see the effective resistances. Now as you can see, the three resistors, 5 ohm, 10 ohm, 30 ohm, they are connected in parallel. So their effective resistance will be given by parallel formula, which is equals to 1 upon Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3. R1 value we are putting it as 5 ohm, R2 is 10 ohm, R3 is 30 ohm. Their LCM is 30. After taking the LCM, if you add them all, 1 upon Rp is 10 by 30. 0, 0 cancel, 1 upon Rp is 1 by 3. But we want the value of Rp. So we will do the reciprocal and we'll get the Rp value as 3 ohm. Right, this is the total resistance when the resistors are connected as shown in the given question. Now let's calculate the total current. So total current already we have calculated, but let's apply Ohm's law. So children, as you can see, Ohm's law is V equals to IR. Now we want to find I. So let's make I subject of formula. R will go in division. So it is V upon R, that is I. Now V is how much? 6 volt. R kitna find kiya? 3. So 6 by 3. So you can see your answer is 2 ampere. The same answer we got by adding I1 plus I2 plus I3. Yes, children? Is it clear? Okay. Bye bye, Vita.